day. This is the Professor, CBMD PhD. And today's Wednesday, June 14th, 2023. It is 5:15 and 3 seconds, p.m. Eastern Daylight Time. And today's research. Modern microscopes use neutrons. So let's jump to it here. New kind of microscope uses neutrons. Date October 4th, 2013. Source: Massachusetts Institute of Technology. Researchers have developed a new concept for a microscope that would use neutrons, subatomic particles with no electric charge, instead of beams of light or electrons, to create high-resolution images. Among other features, neutron-based instruments have the ability to probe inside metal objects, such as fuel cells, batteries, and engines, even when in use, to learn details of their internal structure. Neutron instruments are also uniquely sensitive to magnetic properties and to lighter elements that are important in biological materials. Researchers propose the idea of adapting a 60-year-old concept for a way of focusing X-rays using mirrors to the challenge of building a high-performing neutron microscope. Until now, most neutron instruments have been akin to pinhole cameras, crude imaging systems that simply let light through a tiny opening without efficient optical components. Such devices produce weak images with poor resolution. As for neutrons, there have been no high-quality focusing devices. Essentially, all the neutron instruments developed over a half-century are effectively pinhole cameras. With this new advance, they are turning the field of neutron imaging from the era of pinhole cameras to an era of genuine optics. The new mirror device acts like the imaging forming lens of an optical microscope. Because neutrons interact only minimally with matter, it is difficult to focus beams of them to create a telescope or a microscope. It is well known that light can be reflected by normally non-reflective surfaces, so long as it strikes that surface at a shallow angle. This is the basic physics of a desert mirage. Using the same principles, mirrors with certain coatings can reflect neutrons at shallow angles. The actual instrument uses several reflective cylinders nested one inside the other, so as to increase the surface area available for reflection. The resulting device can improve the performance of existing neutron imaging systems by a factor of 50, allowing for much sharper images, much smaller instruments, or both. The team initially designed and optimized the concept digitally, then fabricated a small test instrument as a proof of principle and demonstrated its performance. As such, an instrument can be used to observe and characterize many kinds of materials and biological samples. Other non-imaging methods that exploit the scattering of neutrons might benefit as well. And because the neutron beams are relatively low energy, they are a much more sensitive scattering probe for phenomena such as how atoms or magnetic moments move in a material. The researchers next plan to build an optimized neutron microscopy system in collaboration, which already has a major neutron beam research facility. The new instrument is expected to cost a few $1,000,000. Researchers point out that a recent major advance in the field was the construction of a 1.4 billion facility that provides a tenfold increase in neutron flux. Given the cost of producing the neutron beams, it is essential to equip them with the most efficient optics possible. And this is the Professor of Advanced Physics, Mathematics, Computer Science, and Leader of Research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.